All right, so we're going to be talking about programming and analysis on a very, very rapid speed type of pace. And the key to this, or the point of this, is really to get the mindset into programming and analysis and everything that comes with it that programming and analysis is about. Um, when I took the programming analysis exam, I took it 3 times. I was stubborn. Actually, the first time I took it, I felt like I did okay. There were some areas I did horrible and I knew it, but mostly okay. Then the second time I took it, I answered the questions that showed up the same way I answered them in the first time. I don't know why. I should have just done them differently, but I was stubborn. I felt like something was just off. And then the third time, um, I did better on section two, and bad on section three, which is interesting. Um, but that's when things started to make sense, and it was that the definition of insanity is doing the same thing over and over, expecting different results. I was expecting that I was gonna pass, but I didn't do things differently. So this report, this static content I came up with is the result of that, me trying to do things differently. And this is kind of what triggered everything else from here on that I used to pass exams. So programming analysis was the genesis of my project planning and design documentaries, I would call them, and project development and documentation documentaries. Those are the 3 exams that I really put together a lot of effort and information. And I got like very geeky about it all. So this is the goal. Again, I photoshopped this just to remind myself that this is the goal. This is what I wanted to do. Pass all the exams. That's the goal, is to pass exams. Nothing else, nothing more. Um, and with that, without much further ado, I divided it into the content area that they had as much as I could understand that they belong to a content area. So the first one is environmental and contextual conditions. It's really all site, site related. The first thing that I encountered on the exam was the idea of where would you put a building in relationship to its microclimate and understanding microclimate. So, like if you're on top of a hill, you're gonna be windy, and if you're on top of a hill, and let's say you are all the way in Texas or in the middle of the desert on Las Vegas, you will want to be on top of the hill because hey, it's breezy and nice, and it's gonna feel a little bit better. It's dry, it's not wet. Um, but if you are in Massachusetts, right, you want to be on the middle of a hill. You wouldn't want to be at the top because it will be too cold. You wouldn't want to be on the bottom because it's also still too windy at the bottom. You want to be in the middle of the slope with south exposure and things like that. So very quickly, I started creating this little sort of play around thing that you can just drag and drop. Where, and this one is where does it feel this way on this place? It's gonna be shady and cold in behind, of course, because it's north, and you're not gonna get south exposure. So behind the hill is gonna feel shady and cold. Um, then if you had a site, let's say in Florida or anywhere, like, but in this case it's in Florida, at 3 p.m., you're supposed to pick one of these storefronts. Which one would you pick to be the best storefront? And storefront has to do with corners are good for storefronts, right? Like you want to be in the corner, but also you don't want to be in shadows. You don't want to be. Maybe you do want to be in shadows because it's gonna be colder. It's Florida, so you want to be in shadows, but you don't. You wouldn't. You want to be in a very prominent space. So there are 2 things that you have to think about here: is what's the sun doing, and what's contextually a good place to put a store. And that's it. So I did this in Rhino and play with it a little bit to understand where I would put it. There were subjects that deal with the different types of materials and what place would you want to put a building in relationship to what the borings. Borings are the holes that we put on the ground to know what the makeup of the air of the earth is, so that we know what kind of foundation we can get. It's typically done. It's always done by your technical engineer, and they created your technical report that gets attached into the surveys and civil plans and all of that, so that the structural engineer, and they make recommendations, so the structural engineer knows what type of foundation to put on that particular location. Um, so this is a very condensed sort of information about it, but the question here is the concept of river delta, which is not necessarily about borings or anything like that, but it's understanding that concept. What is a river delta? So most river deltas or former river deltas are or have been converted into refineries or grain, like where they get, not refinery, I don't know, I would, mines, right? Mines where they get all of the materials that they use for construction, because all of the really nice gravel and really nice stone gets deposited by itself just by the virtue of how the water runs around and takes all the sediment and stuff like that through our rivers, and they create these things. So if you ever asked what is a form of river delta or what will you find, you will find very good soils, very for construction, very good, not soils, I would say very good material, aggregates and things like that. Now, how to read a boring. This is a conceptual boring I came up with in understanding where you will find water. If they ask you where will you find water on boring number 4, well, you will find it in between 8 and 5. If you were asked where will you find water on boring number 2, you will find it at about elevation 8 or so, almost, right? And so forth. Now, this is confusing because typically water is found at elevation 0. That's where you get water, and anything below 0, negative, it will be water, right? So this is not taking that into consideration. I created this diagram, and forget about everything you know about mean of high water, means of high water being, or water table being 0. Is what the diagram is telling you that it is. Don't, so here it tells you that on boring number 4, which is basically the question that I guess I'm trying to answer, it would be between 8 and 5. So you could say it's probably 6.5 or 7. Elevation 7 will have water. Surveys. What is a survey? Things like that. We got to know what that is. So where will you find information about existing easement? The best place you will find it, and there are two places. One in the deed might have information about easement, and the survey will have information about easement. Zoning maps will not have anything about easements, because easements are like utilities and things like that, rights of ways and things like that the town doesn't really know much about. Topographic map is just a topography, so you wouldn't find it there. Now, soil type that is economical and appropriate for shallow foundations. Shallow foundations are, um, the opposite of like keystone foundations, which are very deep footings, or piles foundations, right? So it's your typical foundation that goes down to frost wall. Like the frost walls are about 4 feet in Massachusetts, about 4 or 5 feet. Um, what would you want? Well, you will want what you want on most cases. You will want some nice sand with fine aggregates, gravel, and things like that. You would not want uh clay. You will not want organic materials. You will not want silty clays. You will want gravels, sand mixtures, and a mixture. But never, never, never will you want clay. Never. Now there's this question about dioxin in the environment, and you just have to research what dioxins are and what materials produce them, so that you know how to answer a question about dioxins. So PVC causes dioxins, right? The burning of PVC or PVC itself causes dioxin. So understand that. Causes for radon contamination on a brownfield. These are all the typical ways that radon can get into your building. All right. We will get more detail with these. I wouldn't want you to screenshot any of these or just take notes, but we will get more in detail on these things later. This is just me saying, here's what's coming. All right. Again, we're still gonna have to deal with developments and development rights and what things prohibit a development to happen in a certain location. And it has to do with environmental and contextual conditions. Contextual meaning, is there utilities there? Is there water and sewer? Is there, what's in there? And then also, still in environmental and contextual conditions, when we have to deal with, again, where will you put a shallow foundation? This repeats itself because you may have this type of scenario in many different shapes or forms. Just understand what's the makeup of a space. And these are screenshots from the books that have been recommended. All in, I think, construction is one of the books that they recommend. So I took a picture of what that looks like. What is the organic matter and how important is it? And what would you do if you found organic matter on a site? And this is a construction evaluation type of question too.
Yeah. Can I ask a really quick question? If you need a deep foundation like a caisson, would it be okay to have clay in the soil? Sorry,
yes, that wouldn't be a problem because you're gonna go past the clay. You're gonna go when you do a caisson foundation, it's gonna go down to something called bedrock. That's it. So you can
That's
encounter
fine.
clay all throughout. That doesn't matter. The
Yeah.
foundation, which is a big piece, is gonna
Hmm.
hit clay. That's it.
Yeah. Yeah.
And if it was piles, it still wouldn't matter because piles work on friction, and it's
Hmm.
just the friction of the makeup of all of your materials that will
Yeah.
make that strong.
Yeah. Okay. Got it.
Mhm. Okay. Again, causes for rate of contamination of brownfield. We can we already mentioned it a little bit. Now I do have much more than this. I think I found the shorter PDF out of all my PDFs. This is just 55 pages. I have bigger ones than these, but that's a good start. Codes and regulations is one of the sections. Yeah, we got to get deep into the code here, really, really deep into the code, like how many exits, how to calculate occupant load, how to understand what the role of a mezzanine is in a space when it comes to the occupant load, amount of seats, and things like that. Very, very important. Now, I will walk you through the process as to how to do this. In fact, I have it in here, but I would go step by step, literally step by step, as to how to calculate it, like, for all of this. There is all of these formulas about when the building is sprinkled, when that's not a sprinkle, when there is a perimeter, when there is some frontage and things like that, that will allow you to increase the amount of space that you have on your building, or that you can have. Also, they understanding how to calculate again occupant load and amount of seats that you can have on a basketball court, on a gym. IBC related elements about egress, occupants, fire sprinklers, and accessibility. Then also zoning. That's part of codes. That's a code. That's a law. So zoning. Questions about zoning. Ramps. Questions about ramps. Um, Looking at a ramp and very quickly knowing what the issues are with it and whether they're correct or not. Egress path and things like that. What's the common path of egress? What's the exit discharge? What's the exit? Right? All of those elements. This example is very critical too. How much you can build after you've already built so much. So if you're allowed to build a certain amount of square footage, you got to know how much you have already built, subtracted from what was allowed, and then you know how big your expansion can potentially be. Historic districts, how do we deal with them? Um, Rehabilitation. The guideline, the interiors, the Secretary of Interior's guideline for historic buildings for rehabilitation. Uh, so there's rehab, restoration, I think reconstruction of historic buildings, right? So how to do that? And I have the PDF of that, and I can share it with you. Um, Things like that. If you change one classification from one to another, what happens to your building? If it was going to be a type 5B construction and then now it's 2B construction, what does that mean? Or vice versa. Because this is all happening at the programmatic level before we really, before we do a real schematic construction design development, we got to know what type of construction we're going to use, and this helps the owners with their pro forma when they're doing the planning. And I go through the whole process as to what would imply to do X or B or C or whatever. FEMA, information about FEMA and flood zones and things like that. So what things can you build on a flood zone? Accessibility paths. Check all that apply type of questions. Site analysis and programming. This is much. So before it was environmental and construction conditions. Now we're talking about real site analysis and programming. So like, where would you put a building according to a criteria? These are the buildings, you drag them and drop them where they're supposed to go. And I was generous enough to come up with some very nice example that looks kind of like the exam, honestly, to be able to drag and drop where these things go. This diagram, I was hunting it for a long time because I experienced something similar. And it's what are the advantages or disadvantages of each one of these sites? And then another type of example, where would you locate a building following this criteria? Right? And I put where I would locate it. Right? And this explains why I would locate it there. Okay. Now, where would you locate a pond, a townhouse, and a department store after looking at this site? So it looks like it's going all the way down here. So pond will be great there. This is parking, by the way. And so the department store could probably be right next to the parking, and the townhouses could be right here. Now, there's a criteria to this. I didn't provide it, but I'm telling you, this is how I will go about it. Locate a pool, locate appropriate shadow and pool for better sun exposure at 3 p.m. So if you know what at 3 p.m. the sun's gonna be anywhere, like if they tell Florida, then you will know this is the pool and this is the building with the shadows. You wanna, how we want to do it. If it's in Massachusetts, I would never want the pool to be in the shadows. I would want it to always be hot, nice and toasty. So forth, and these are the setbacks and this is the proper line. Long exposures, a bunch of them. Where's the sun at 3? Where's the sun at 4? Where's the sun at 5? Where's the sun at 6? Where's the sun at 5 in Massachusetts? Where's the sun at 5 in North Dakota? Where's the sun at 5 in Florida? Locating a building on a site. This is a map, bike lane. This is a very diagrammatic map. Where will you put your building? Depending on the criteria. Here's the criteria. Locating a retention pond. Difference between retention pond and a detention pond. A retention pond keeps it all year round. A detention pond holds it for a little while. Imagine you went to detention at school. They didn't keep you there, they'll let you go eventually. But if they were to retain you, like somebody in jail was retained, not just detained, retained, it means that they kept it. I've retained all of my money, you know, retaining is just entertaining it for a little while. So understand that in the terms of not in detention or school, but in the terms of this. You are giving a diagram like this and you're giving a criteria. Where will you put the different uses of the space within this here? Very straightforward. Follow the criteria. Criteria will tell you what they want. Lawyers want views. Accountants want it to be next to the lawyers. Apartments want views. Coffee shop will want to have a little drive-through. There's a drive-through in there. The florist doesn't need a drive-through, but still, it needs a traverse road to bring all the flowers there. So things like that. This is very, very good stuff. Very good. Again, also, questions about subdivisions and things like that. Type of type of elements that define a building depending on the region in which it's gonna be built. What's the repair and buffer and where would it be? Repair and buffer is near water. So if this is the high point, HP, this is the low point, repair and buffers are always within the buffer zone. And this is an example. So all of this is repair and buffer right here. Building analysis and programming. This is getting more into the real building. You saw how all of the others had to do with the site and conditions, things like that. Now it's really about the building. So like program. If a nurse or a doctor wants certain amount of offices, how do you locate them in relationship to their program? These diagrams come in handy right here. This is an amazing diagram, amazing for programming. So just following the criteria. But now you know what your mode is. This is a very fun exam. It's very, very fun exam overall. They show it in plans, they show it in sections, they show you different types of scenarios. You just got to read the criteria and follow through with it. Different types of developments, also different type of organization. There's a criteria to this. You know, Floors and bathrooms typically go together. Vice presidents and presidents typically one corner offices. Things like that. You start understanding how to organize the space. Okay, questions about columns and locations, and there are analysis of existing buildings too, like existing buildings, brownfield buildings and things like that. Like, what would you do there with that building? There's a bunch of stuff that we can read. Questions about buildings and programs, things like that. Again, dragging spaces even though this is also grabbing spaces within a site, but it's also about relationship between one space and the other. So this could belong in the environmental and contextual condition or site analysis, but it also belongs here. And then other questions about FARs, stories. Efficiency ratios, very, very important to understand how to calculate efficiency ratios. Means of egress, FARs, water savings, sustainability guidelines, very early on sustainability guidelines. Now, this is not my biggest. This is actually a very short report. This is not everything at all. Actually, this is not even a quarter of what I have. So I just didn't find the proper PDF, but this gets your mind into the thinking about this. I think this was my round one. So think about 3 rounds. All right. So this is very good. I hope this is helpful and we can have another session where we can really dive deeper into it.